Good day, friends. So, just kind of review here. I'm going to go over another lecture. You haven't seen this PowerPoint, I'll attach it as well. I just want to try to make things a little more clear. That first PowerPoint we used and I lectured through really didn't have a lot of pictures or explanations, mostly just definitions. It is what it is. You did a lot of readings and some videos. So I think you have a good enough background to understand what we're going to review today. Okay, so I'm going to go through a new lecture and it'll be with the same material. And I think you have enough background now to really understand and put the pieces together. So first, when we're talking about the universe, physics, chemistry, that's what physical systems is. I'm sorry, we're studying chemical systems, but they go hand in hand. So in chemical systems, it's about the chemistry and the physics of how the universe works and what it's made of and comprised of at its ultimately fundamental smallest particles. Okay, so smallest functional unit or any unit that holds a property of any kind of matter, whether we're talking about air, skin, a hammer, a basketball, books, smartphone, everything is made of something, right? What is this case made out of? What is this glass made out of? Well, we give it different names like silicone, polymers, glass, plastic, rubber, steel. Okay, so what is steel? What is rubber? What is air? Ultimately, you're talking about compounds and mixtures of substances, right? Compounds and mixtures of substances. So look at this picture here on your screen, and we're going to say all matter, whether hammers, basketballs, or phones, or animals. They're made of matter. Everything's made of matter. We established this. And matter exists in a gaseous state, that's like air. It can be in a solid state, like the hammer, steel, or it can be in a liquid state, like water, right? Clearly, and anything dissolved in water. So those were the states of matter: solid, liquid, gas. You can change states of matter simply by adding heat. And you go from solid to liquid and liquid to gas just by adding heat. And likewise, removing heat, you go from the gas and you can condensate it to a liquid. And if you remove more heat, you freeze it into a solid. Okay, so those are states of matter, but it doesn't say anything about what that matter is made of. Why? Why is steel so hard at the same temperature that water is a liquid? Sounds like a dumb question, right? But there is an actual answer, and this is how we get at it. Why is air a gas when when water is a liquid? Why isn't water gas? Why isn't the air a liquid? You know, silly questions. But there's a reason, and that reason comes down to the properties of that substance. So this lecture is not about the properties of the substance, although some air is flammable, some is not. And when I say air, it's because air itself is right here. It's a mixture of substances. It's a homogeneous mixture. You have oxygen gas, nitrogen gas, hydrogen gas, and even some water vapor droplets in the air. That's what you call humidity. So you have all these components that make up air. So air is not a pure substance. Air is a mixture. It's a homogeneous mixture. Homogeneous because it's evenly dispersed throughout, evenly mixed up. All right. The material that makes up a hammer is hard because of the compounds that make it up. So a compound is a pure substance, like steel. I mean, to have that, it was melted down, it was heated really high. That's a physical property of steel. You have to heat it up really high to get it to go into a liquid form. And then you can pour it into a mold that looks like a hammer, because we don't go digging for hammers, right? We make hammers out of a compound that we call steel, which has different kinds of metals in it. All right. And then all of a sudden, of course, we let it just cool off to room temperature. And at room temperature, metals tend to be solid. They freeze very quickly. It takes high heat to melt them and higher heat to vaporize them. Other things become a liquid rather quickly, like water. Okay, so that's just kind of getting to think about matter, getting to think about basic questions. Why is it soft, hard, liquid, gas? Well, it's liquid, gas, and solid because of the matter it's made of. So that matter can be variable. Variable means it changes, it's different, okay? Now, not all of matter is variable. That is, not all matter has different things in it. So ask yourself a question. Is the composition of this matter variable? Does it have different things in it? If the answer is no, then it's a pure substance. Now, of course, you wouldn't know this just from memory. This is what the science is about. And unfortunately, we do 2 labs in class with this. We did 0 online. Well, we did 1, I think, at home lab. But anyway, pure substances. So pure substances can be separated into simpler substances. If it can be, then it is a compound. Can the pure substance not be separated? Then it's an element. And this is the element like those on the periodic table. So this is the last slide today, and it's the first slide. So what I would do, if you want, is to pause this and just write down this. Matter can be broken into pure substances or mixtures. And then pure substances can be broken down into elements or compounds. Compounds have 2 or more elements. Mixtures can be one of 2. They can be either heterogeneous or they can be homogeneous. Okay, so now I'm going to exit out real quick and I'm going to go to the very first slide and review this with you. So pure substances, let's go back to pure substances. So a sample of matter that has a very definite chemical physical property, okay? So if you look on the lower left, this is a single molecule, let's say oxygen gas, 2 oxygen molecules. It's one kind of element, so it is a pure substance. Compounds have 2 or more substances. So you can still see it has oxygen here and 2 hydrogen. Even though there's 2 different elements, we call it a compound because they're bonded together, chemically bonded. That's going to be a key point. I'll say it again, chemically bonded. That's a key point between understanding the difference in a pure substance versus a mixture later, okay? So if they're similar atoms bonded as a molecule, it's a pure substance. If it's a compound, it's a pure substance. The reason it's a compound and not just a molecule is because it has 2 different elements, not only one kind of element. So look at the picture there and compare if this dumb thing goes away. All right, so elements are pure substances that cannot be separated into simpler substances by any physical or chemical means, okay? So this is our periodic table of elements, which we will be having a full lesson on coming up next week. No. Starting, yes. What are we, chemical systems? Right, next week. Hydrogen, helium, we have lithium, beryllium, boron, carbon, nitrogen. Each of these things in and of themselves, here's copper, where'd copper go? Cu is copper, Zn is zinc, sodium, Na, sodium chloride, like salt, NaCl. So in chemical systems, you're gonna see this. Again, more detail. All right, so elements are these. When we say elements, we're not just saying earth, wind, fire. You know, oh, what kind of elemental makeup is that? No, very specifically, when we're talking elements, we're talking about these things right here. If we go way over here to the far right, we have helium, neon, argon, okay? Fluorine, chlorine, oxygen, nitrogen, carbon. You might have heard of some of these before. You don't have to memorize this at all. I just want to say the names to you so you begin to get a reference of what some of these pure substances are as elements. Now, compounds will have 2 of these elements. So water, for instance, has hydrogen and oxygen, number 1 and number 8, combined as one kind of molecule. So a glass of water is filled with H2O, which is the chemical compound of hydrogen and oxygen. So it is a pure substance, but it's called a compound, not just an element. If it was only hydrogen, it'd be a gas, and that's an element. If it was only oxygen, it would be an element, gas. But when you put oxygen and hydrogen together, it's still a pure substance, but it's a compound because it makes something new. So pure substances composed of 2 or more different elements joined by chemical bonds, which we'll learn about, then you have a compound. So here's some formulas for very common. This is carbon dioxide. This is sodium chloride, salt, and this is H2O, water. These are all compounds. They're made of 2 or more elements, but they're pure substances. So they're made of elements into a specific ratio, like 2 to 1, 1 to 1, 1 to 2. They have a chemical formula, and they can only be separated by a chemical means. They cannot physically be separated, okay? So compounds can only be chemically separated. That means you have to do something to them to cause them to release, so they're pure. Mixtures, all right? Let's get on to these. So a combination. So we've just talked about 2 kinds of substances. What were they? Elements and compounds. Elements and compounds are pure substances. What if you have 2 pure substances? 2 compounds that come together and get mixed up. What if you have an element and another compound that don't bond, but they're together somewhere? Then that's called a mixture. So a mixture is a combination of 2 or more pure substances that are not chemically combined. So substances held together by physical forces, not chemical, okay? Substances are held together by physical forces. So the glass container is keeping them together, all right? They're not chemically bound, you know, they're not a true bond, they're just together, not bound together in a chemical reaction. So no chemical change is taking place. Each item retains, it keeps the properties within that mixture, and therefore they can be separated physically. Go to the last slide. Remember the compounds can only be separated by chemical means, not physical. Mixtures can be separated physically, I should say physically. So how do we do that? There's a process called distillation where we distill it. And, oh, where's my drawing? I'll try to draw it here for you real quick, okay? It's gonna be a bad drawing, but I'm gonna try. So if you have water right here, all right, and we can add fire to the bottom of the water, the vapor, right, begins to rise. But if we kept that, and let's put a tube over it, let's just call that a tube, and here's another empty container. So if you add fire to water, that water is going to begin to evaporate. It'll go into that tube and swirl, but as it gets over here, it's going to get cooler. And what happens when we cool steam? It condenses into a liquid, and then that liquid drips down. And it runs down, and we fill up something over here, and we get new water. Well, guess what? Water as a substance has a physical property of going from boiling, going from liquid boiling into a vapor at about 212 degrees Fahrenheit. So if we get to 212 degrees Fahrenheit, the water is boiling and steam is rising. But up here, it's not 212 degrees, right? Where it's getting darker blue, my finger is drawing. So right there, it begins to condense. It cools off cooler than 212 degrees and begins to reform into a liquid that then drips down gravity into here and becomes a liquid again. But guess what stayed over here in the water? all the other impurities, the other substances. Remember, a mixture is a combination of two or more substances, okay? So water as a compound was separated from other pure substances, which often could be salt or could be sugar. The salt and sugar are not going to evaporate. Their physical properties, because of what they're made of, do not allow them to boil at 212 degrees. Instead, they will stay down. And this is how we chemically separate it, or physically separate it. We physically separate it with heat. And this is called distillation. We distilled the water. So if you ever wondered why you call it distilled water or purified water, we boiled it. The heat rose, and that heat is pure water. It condenses from steam into a liquid and comes down on the other side as pure water over here. And what's left over here are the impurities. Isn't that cool? So that's how we can separate it. That's just one example. Let me clear all this and let us go back. Maybe. There we are. So I want you to pause this, and I want you to take some time to look at the difference between mixture and compounds. Please don't write all this down. It's way too much. And I want you to look at these properties right here. Each substance in a mixture, each substance in the mixture keeps its own properties, which is why the sugar and the salt stayed on the one side and water vaporized and went to the other side. A compound, the compound has properties different from the elements it contains. So let's think of water. Oxygen is different than hydrogen. If we were able to separate that compound, oxygen and hydrogen by themselves behave differently than they do together as a liquid. I mean, think about that. Oxygen is a gas. Hydrogen is a gas. At the same temperature, though, when those two come together, they form a liquid. The liquid water is nothing like oxygen or hydrogen. Isn't that crazy? That's crazy. But that's what it is. That's what a compound is. It has totally different properties from the elements it contains. So go ahead and pause this and think about then, see if you recognize the difference between mixtures and compounds. Okay, so hopefully you went through there. Now I want you to also pause and read through these definitions. Can you identify the following? Element, one type of atom. Compound, two or more atoms joined together chemically. Mixture, two or more different substances, meaning elements or compounds, that are only physically joined together, not chemically. And then it can contain both elements and compounds. Why can it contain both? Because it's a mixture. All right, let's practice. Let's go through. The rest is a series. Element, compound, or mixture, your choice. Rocks. You can pause. Think about it. All right, so if we look, rocks are pretty grainy. And when you look close enough, and most rocks, but not all rocks, you can see it. There's individual sparkles and quartz looking black, pink, gray, brown. So these are solid substances that have been physically combined over pressure, time, heat. So rocks are mixtures. All right, hopefully you said that. It's a mixture of different substances, sediments that have settled at the bottom of water over time and got compressed into rock. So rocks are mixtures. All right, pause this and think about it. Element, compound, or mixture. What is copper? We can see copper is ductile. It can be strewn into a metal easily. Hopefully you said element. It's a pure element. Copper is one of those that happens to be on the periodic table. If you did not know that, you do now. All right, element, compound, or mixture. Jelly beans. Pause to think about it. All right, so look at these. You have a cluster of red. You have purple strewn across the bottom, orange. Can you separate out any of these colors? Yes, you can. Therefore, it is a mixture, or it represents a mixture. Ooh, here's a tough one, huh? Element, compound, or mixture, table sugar. Well, when you look at sugar, you see all the white crystals look the same. But what make up those white crystals? Well, there is no such thing as the element sugar. Okay, it's not on the periodic table. Sugar, therefore, is a compound. It's actually made of carbon, hydrogen, and oxygen in this ratio, 1 to 2 to 1. Okay, so it is a pure substance. Sugar could be considered a pure substance. It is only CHO chemically combined. So it's a compound, and therefore it is also a pure substance. Diamond, pause to think. What are diamonds made of? Carbon, and only carbon. Therefore, diamond is a good example of an element. If the diamond has any other colors, then it's impure. So rubies, sapphires, all right, emeralds, these are all diamonds with other impurities, but they're homogeneous impurities such that they have a nice color of red, green, or blue. How about tea? Hot water over a bag, extracts the chemicals in those tea leaves, flavors the water, you put a little sugar, mix it up. What is it? Element, compound, or mixture? Mixture. That's right. Remember, we could distill it. We add heat, and the water would vaporize off. You'd be left with this brown stain inside the glass, probably, and all the water will have come out. So you were able and can separate it by distilling it. Therefore, it's a mixture. Salt. Element, compound, or mixture. Again, you will not find the element salt on a periodic table. Salt by itself, it's white crystals just like sugar was. Therefore, it is compound. It's made of 2 elements, actually. Compounds are 2 or more. So here we have sodium and chlorine. This is filled with neon gas. Neon happens to be on the periodic table. Salad. Is lettuce bonded together? Nope. Only physically held together in your bowl. Therefore, it is, guess? That's right, a mixture. Element, compound, or mixture. This one you ought to know real well by now. Pause, think about it. It is a compound, okay? Water. Again, hydrogen and oxygen, 2 different things, 2 elements, chemically bound together form water. Therefore, it's a compound. Aluminum. On the periodic table. And you can look at your periodic table for any of these questions. Of course, now I'm telling you it's a little late. Lemonade, here's the big one. What is it? Again, like most substances dissolved in water for flavored beverages, it's a mixture. We can extract water out of the lemon juice, okay? Silver, get out your periodic table, and you'll see it is there. Sand, get out your periodic table. There is no sand on the periodic table, but you will find that sand is made of silicon and many other materials. Therefore, it is a mixture. Okay, you can separate out the different substances. All right, so now we're back to our last slide, which we started with, and I want you to go through this table again and see if you can understand by looking at these pictures down here. Helium, all these are the same element. These are all the same element, a uniform similarity between those atoms. Compounds, even though they're made of 2 different atoms, that is 2 different elements, a red and white, which is oxygen and water, nonetheless, every single particle in there is identical to the other particles. They're chemically bound together. Therefore, pure water is a compound. Heterogeneous just means it's all mixed up. So you got different things like wet sand, you have the water here, sand suspended. It's a heterogeneous sand. If you put sand in water, generally the sand will go all the way down, the water will stay at the top. And so it's not evenly dispersed. Like suspensions or Tylenol, children's Tylenol, you have to mix up the children's Tylenol because it all settles at the bottom. That's a suspension. It's a heterogeneous suspension, so you have to shake it up. A solution, which you can get a solution of Tylenol solution or syrup, that would be homogeneous. That means it's tiny enough particles that it's already dissolved with the tea, or tea in this case, Tylenol in the medicine. So it's evenly dispersed. This is really not a good picture, actually. These two are not good pictures, but hopefully you get the idea. That's it. That's a review of compounds, mixtures with a little bit of matter, states of matter, and with a little bit of physical and chemical properties thrown in there for good application. Okay, well, hope that helps.